Hello. This video will go over our research titled Efficient Multistage Inference on Tabular Data. Our work addresses a common challenge in machine learning applications, which is the bottleneck in real-time inference. Many existing systems favor separating machine learning code into services queried by product code via remote procedure call APIs, but this separation introduces network latency and CPU overhead. The solution explored in our work is to process at least some inferences quickly with a simple model embedded into product code to bring down a mean latency when possible and fall back on RPC APIs when necessary. To reduce API latency and avoid CPU overhead of network communications, it is important to make the first stage model dramatically simpler than the second stage model accessed via RPC. We developed such multi-stage inference in detail here and show that it produces consistently good results for various tabular datasets. Our multi-stage inference model is called logistic regression with bins. We start by using a model-free feature ranking. Then we split the most important features into quantiles. Each data point then falls into an ordered tuple bin on which a logistic regression model is trained. The performance of each model is compared to the remote procedure call model. And the crucial role of AUTOML is in configuring the first stage inference by picking the optimal hyperparameters and by balancing the two stages as to maximize the use of the first stage model while minimizing the loss in machine learning performance. Here, we plot common performance metrics as our multi-stage model uses more and more of the first stage model for inference, going left to right. We showed this for 3 different cases indicated by color. The dashed line indicates the performance using the RPC model for all inference, while the solid line represents using the multi-stage model. The very slight decline in machine learning performance allows a sizable fraction of the data to be handled by logistic regression with bins, the multi-stage model, with minimal loss in performance. Our key insight is that heavy use of the first stage model entails only a very small machine learning performance loss. By applying our approach, we reduce inference latency 1.3 times, as can be seen in this table, where we time the latencies for each of the candidate models. The first one is the first stage inference model, then the second stage inference model exclusively, which is called via RPC. Then the hybrid model, multi-stage, where we call it 50% of the time, just as our as a baseline. And we can see that we are about 1.3 times faster. The method also reduces CPU resources by 30% and network communication between application front-end and machine learning back-end by about 50% for a commercial end-to-end machine learning platform that serves millions of real-time decisions per second. This is shown in this table where the results are the first 4 results for private data sets. And we also show for a number of public data sets where we get comparable performance to an XGBoost model while still getting significant coverage of the data set. So we are using our first stage model for often about 50% of the inference. This is our results. Please see our work for more details.